Hello, ladies and gentlemen.
Hello.
Lesson learned number one when you do microservices, there's never enough cables. We were a little bit stressed, but now everything is back to order because all these little computers need to be synchronized with dates. So lesson two, learn with microservices, make sure your servers have the same timestamp. That's why we had to put these cables so they could synchronize on the internet and get the right timing.
Yeah, the issue here is that the Pis don't have batteries, so they're not able to keep the same date time, and that causes issues when you connect them again without internet. So all of them get unsynced, and then it's an issue. So as long as we don't trip on this cable, then we'll be fine.
The demos might be okay. So, hello everyone. Welcome to our deep dive session, Baking a Microservice Pie. So we will have a 3 hours session. So what we'll do is we'll have a break in the middle, a 30 minutes break, around 11-ish. So it's not a lab. I was talking to other people, and this morning there's deep dives and labs. So the difference is a lab you code, a deep dive we code. So you won't be actually doing any coding because we have 12 pies each. So if we had to multiply that.
Well, actually, we have all this code that we're going to show on GitHub. So we actually provide Docker images and Docker Compose images that basically can run on your own local host. So they can actually, if you want, you can keep along, and instead of running on the pies, you run on a Docker Compose on your box.
And we actually we will give you the GitHub link, but we even have photos and all the hardwares. If you want to build that at home, why would you do that? But if you want to do that, we have all the devices, all the little cables. We have, all the information.
So actually, if someone wants to run on Docker Compose on your local box, it will be awesome because then you can tell us the bugs that we have,
Yes.
Most likely have. Oh, it's me. Careful with the cable. Hello, guys. So thank you so much for coming. It's really awesome to see this full room, especially considering they had some awesome talks happening at the same time. So I'm Roberto Cortez. I live in Portugal, working for this company called Tommy Tribe. I don't know if you heard about it. Basically, it's a company that supports Tommy, the application server based on Tomcat. Other than that, I've been working on the software industry for the last 10 years, mostly on finance, government, health, and mostly on enterprise Java. So I'll be happy to be here with you guys. So thank you so much for having me.
And my name is Antonio Goncalves. I'm also Portuguese like this guy, but he lives in Portugal. I live in Paris. I've been working in the IT industry a little bit longer than this guy. Mostly Java. Even, if at the beginning I was doing C++, etc., etc. But actually, when I look at my career, I've mostly worked with distributed systems. I'm a former BA, employee. I used to work for BA Systems. So I've mostly worked in distributed systems. I was doing, my thesis was actually on Corba for the older review. And today we call that microservices, but the problems are still the same. It's trying to deal with distributed systems. So we will show you that, I'm sure you know it, but distributed systems are hard, and we will show you what to do when things go wrong. So we will be, during these 3 hours, we will take you through our journey of microservice architecture. As I said, just change the microservice buzzword, put SOA or distributed systems. What we will be showing you today, it's all the problems that we have when doing microservices distributed as architectures. So we will progressively build something that hopefully will work at the end. But this journey we will go from it's working, but there is an issue. Let's solve it. Oh, it's working better, but there's another issue, etc., etc. So we will try to go from problem to solution, from problem to solution to problem. And we will end up with something basics in terms of business logic, but quite complex, as you will see, in terms of distributed systems. Because we have 3 hours, and we will be doing most of the talking, do not hesitate to interrupt and ask a question. It's a bit messy here, so there's plenty of cables. We can explain things as we go. So do not hesitate to raise your hand, ask a question. We will repeat it on the mic, and that will also help us to bring you more information if we forget. So I'm going to start with a full demo. Here, so we have 2 clusters, but they are separated. It's just because demos can go wrong, so we duplicated
redundancy.
The redundancy. But they are not linked together. So we have several colors. So as you can see, the orange at the bottom are those guys here. It's the servers. So on the orange pies, we will put 1 microservice 4 times. Then on the reds, so the 2 guys up there, we have a second microservice that talks to the other one. And then we need a bit of infrastructure. So we have some purples here at the bottom. That's where we'll have the gateway and the registry. We will explain you what it is. And then we have the blacks in the middle, 4 blacks, but we actually only use 3. 1 is for the web application, and 2, the 2 grays there, it's to inject some load so we can see, things moving. Otherwise, we don't have logs, we don't have anything. And we have our Mac, and so we can show you some logs, we can show you some things. So the Mac is linked to the router. The router, each Pi and the Mac is connected to the router. We have a few switches. And all these pieces work together. So now I'm going to show you the final application we will be doing.
Yeah, so just to add, we're also running an elk stack for monitoring. Unfortunately, that was the only thing that we're not able to run on the Pis because it takes so much memory. So if anyone here is able to have a try to run elk on the Pis and was able to do it, please let me know because I would like to do that as well.
An e-commerce website where you can log in, you can log out. Then we have 1 microservice. So the idea is to sell books. And when you create a book, you need a number, an ISBN number. So we have 1 microservice that generates random numbers. So here, each time I click, it goes to one of the orange instances doing round robin. Okay. And then, we have books. So this list, actually moves because, as I said, we have 2 injectors. And the 2 injectors create books, get some books, delete books. So now if I refresh, the number for
Don't hit refresh.
Yeah, don't hit refresh. I have to say that, doing all the distributed demos was tough, but writing a decent website was also tough. So yeah, this list just evolves with time because some books will get deleted, some books will get created by the injectors. But I can also create a book. I don't know, Matrix, John Doe, up. And as you can see here, the ISBN number is gray. I can't put an ISBN number. So when I create this new book, is it created?
He probably went to the other server.
Oh yeah, that's true. Yeah.
You can go to the tabs where you have the JSON.
We will explain you why, because we didn't want to mess up with database, so we don't have one database, we have two, and sometimes you create on one and you get on the other. Anyway.
You have the tabs where you have the JSON responses,
yeah.
So you can show there.
So just to show you that when you create a book, we invoke one microservice who's responsible to create a book, and this microservice actually invokes the other microservice that generates a number. That's all for the web part. But then we have to see things moving. We have a dashboard here, a Kibana dashboard. And so on this chart here, you have the 4 servers. So that's the orange guys. And these are the ones used to create and retrieve books. So it changes because, it's not always 25% each, because the simulators just inject load randomly on different nodes. So here, I can see that I have the 4 servers creating books, deleting books, etc. Here, actually, we have the 200 HTTP codes, so that's the number of gets that we do. So here, the injectors are getting books. That's why we have 200. We also have 404 because we get random strings. We create books, so that's the 201. And we delete, that's the 204. And we have a few 400 because we inject junk. We try to create books with wrong data and so on. These are the number of counts on the number API. So the API that creates, that returns an ID, an ISBN number. And here, the number of counts on the book API. So as you can see, it's alive and kicking because we have the 2 simulators injecting load. And we will show you that to reach this point, we need a gateway. We will explain you why. And to not get lost in this distributed system, we use a Consul, which is a registry. And we know what is where. And we can move things around. So, we can take the microservice, the book microservice, and move it from the orange to the red. And the registry will, discover that it has changed. And just to show you that all this is, REST calls, here I'm doing an HTTP GET on books. And this list might change because the injectors might delete books. So here I have the book API. I'm doing a GET on one node and on a second node. And here I have the number API, which is just a HTTP GET that returns a random number. So this is the demo. As you can see, not too complex in terms of business. We don't even have a single database. Our business logic is very simple. But it's full of cables and always goes wrong. So that's the story we will be telling during these 3 hours. So the architecture, microservices, of course. We have monitoring, as we show you, with Kibana. Configuration. Quickly, we will see that moving things around, we have a problem. You know, we need to configure the IP address, the port that might change. So we will need to introduce configuration. The discovery, you know, we decided to put microservice A on the orange and B on the reds, but things can change. So that's why you need to know what is where. Load balancing, we will explain you why, but the book API can get a number out of the 4 instances of the number API. So it needs to load balance. So I'm load balancing, but each microservice also needs to load balance. And circuit breaker, because at the very end we will unplug cables. And when you unplug a cable, it should keep on working. And a gateway. So all that is there. Oh, yes, and security, of course, because we need to log in and log out, as I show you. So in terms of hardware, as we said, you know, everything is on our GitHub page. So if we want to do that, you can. So we have our Mac, because that's where we run ELK, because as you said, can't run on a Raspberry Pi, too much memory and so on. And then we bought 12 of these little guys, so we have 12 Raspberry Pis, 1 router here, 3 switches, and plenty of cables that will allow us to plug and plug things. In terms of software, the back end is in Java, the front end is in Angular, but we will be looking at a bit of code, but you know, actually when we started, we wanted to do 1 microservice in Go, 1 in Node.js, 1 in Java, and gee, so we just you know, stayed on our comfort zone. So we did Java because you know, as you will see, it's very, very complex to have all these up and running. And if you start to have several languages and frameworks and library, it was a bit tough for us.
I mean, it was definitely possible, but we pretty much ran out of time, like working all of these things. Maybe for the next version.
So we're just doing Java on the back end and TypeScript on the front end.
Maybe in Kotlin now. Kotlin is super popular.
Yeah, Kotlin maybe, Go. We will be talking a little bit of microprofile. That's what we've used, you know, which is a subset, a superset of Java, let's say, not a subset of Java EE. And in terms of servers, because these are, you know, web servers running, we use 2 web servers, Tommy and Wildfly Swarm. We use Nginx for the HTTP server, ELK for the monitoring. We use a fairly bunch of the Netflix OSS stack, not all of it, but most of it. So, you know, again, we will explain you. Consul for the registry. And we need a gateway, so we took the Tommy Tribe gateway. And again, we will explain that as we go. In terms of infrastructure, if we look at inside those guys, so the Raspberry Pis are running Hystrix OS, which is an operating system made for running Docker images. To push the demos, because we will be coding on our Macs, building a Docker image, running the Docker image locally even, but then we have to push the Docker image to the Raspberry Pis through this cable. So we use Ansible, and again we will explain you a little bit. Docker, so everything is Dockerized, otherwise it's too complex. Docker Compose. As for the database, well, we use H2 in memory. This is bad, but you know, again, actually the purple ones were supposed to be the database. We wanted to put a PostgreSQL and synchronize them. And again, they're running out of time, running out of pies, running out of... it's very, very complex. and we will talk a little bit about that, but when you do microservices, all the wiring and cabling is difficult, but the most difficult part is business related. You know, if you buy a DDD book, if you go to DDD conferences, having a business that you cut in different pieces, that's the hardest. Plus, every microservice needs to be isolated in terms of data. You don't share a database, so you need to synchronize data. You have several patterns. It's very, very complex. That's why we didn't do it.
Maybe for a baking pie session number 2?
The return of the comeback.
Yeah.
So yeah, that's what we will be building in 3 hours. So that was just the demo, some bits and pieces. But before starting to code, let's step back a little bit and just spend a few minutes talking about microservices. Have you heard of microservices? Raise your hand if yes. Raise the other hand if no. Okay, so
everyone.
Nobody was locked in a cave for the last 2 years. Good. Who uses microservices on a day-to-day life?
Oh, wow.
Don't be shy if you call it SOA. It's fine. Who plays at home with microservices and would love to do that on their day-to-day job? Yeah? Okay.
Just a couple.
Yeah, okay. After this talk, you might change your mind. Okay, and who likes it? You know, who goes to work the morning and says, yes, distributed systems, it's going to be great.
Who likes microservices? Everyone.
Yeah, everyone,
no,
cool.
But we don't, actually.
Okay, and who suffers from microservices? We suffer.
Okay, so I remember last session no one suffered. Now we had a couple of people that are suffering, so I guess in that evolution.
I think, what we learned here during doing this talk and preparing this talk is everybody has a role. You know, the network engineer, God bless the network engineer. Because when we do microservices, we usually stop on the code and give it to someone else. When you have to deal with those little things, it's really, really tricky. It's always falling, etc., etc. And you think, God, in your company, there's a bunch of guys doing network. Good on them. Thanks,
Buy them lunch
at the end of the
sometime.
day, at the end of the day, my code can run because, doing microservices from hardware to software is really tough. How big is a micro? Does anybody has a definition?
1 million lines of code? No. 5,000? No. 2,000?
Small autonomous service working together. Sounds like a good definition.
500 lines of code? No, I mean, they're doing very small microservices. 100 lines of code. Oh, there's like one over there. 50 lines of code.
I quite like this one.
50 lines of code.
50?
No. 50, no.
That's ours. That's
yeah.
our... Small enough, but not too small. I quite like that. Can be written in 2 weeks, so it's not line of codes related, but kind of.
I don't know. Some people think that are lines of code based. So.
And then, because nobody really knows what a microservice is, but on all those definitions that we took online, because some of them are quite funny, it goes down to, again, the business that you are trying to solve. So this sentence is quite, accurate, single responsibility principle. But again, what is a single responsibility? So it's really, really difficult to put boundaries. And you have to go back to the domain-driven design to try to figure out what is the boundary of your microservice. In our case, it's quite easy. We have one microservice that creates numbers, another one that creates books. We wanted to have another one for the shopping cart, and another one for the catalog. So you can think of things like that. But it's really tough, reaches a point where you are dealing with part of your business and you don't know if you have to put it on the right side or on the left side. So I don't know how many lines of code it's micro, but it's definitely related to your business logic, and that's the hardest thing to do for us techies. You need to understand the business. You need to create boundaries about this business. So here is just simple, but when I go back to my customers, they have complex business systems, and it's difficult to cut that out in microservices. Blah 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 blah. I love this definition.
You skipped something
over
there.
Skipped the blah blah blah.
Yeah, no. What the hell is hexagonal
architecture? Hexagonal architecture. I don't know. I quite like this one. A microservice is built by a team that can eat with 2 pizzas. I don't know if you've heard this definition. I quite like it. So why microservices? Why is all this fuss about microservice today? Again, we're coming back to the business. If you're a business focus, you can deliver new features quickly. And actually, in our little example, that's what's going to happen. We have one microservice that works, and we don't touch it, and we need to add some functionalities to the second one. We don't touch the first one. So that's also one thing about microservices. Business focus with not so much interaction with the outside world, with the other microservices. So you can deliver features quicker. Of course, the teams are smaller, so more agile, less meetings, less. Even though if you are building an entire a single system at the end of the day, you have 7 different teams, you always need a bit of coordination for the UI and things like that. But hey, the good thing is what we do here is when you go to microservices, sometimes it's also because of load and scaling. The good thing is if they are all divided and all separated and stateless, you can scale them independently. That's what we do. We have 4 instances of number APIs and 2 instances of book APIs. And we can change that. If we look at the logs and if we can see that one is struggling, you can take one microservice and scale it and not the other one. So that's also a good reason to move to microservices, which goes hand in hand to address unpredictable loads. If you are selling books, for Christmas, you will be selling more books. So you can, scale the microservices that will be impacted by Christmas. And the cloud. If you have several small things, you can scale on-premise in your data center. If you're scared of Christmas coming, you can also scale out of your data center and go partially to the cloud. So you can say, I have my microservices in my own data center, but Christmas is coming. I take all these microservices, scale them out, and in 2 weeks' time, I take them back. So that's also a use case I see. Okay, so let's start simple. We're going to start creating our number API service. And one Angular, application, so we can interact with it and visualize some things. So in this first demo, we will only use 2 pies. One, we will push the number API, one instance, and the second pie, the Angular application with Nginx. And we will deploy them on the pies. So the architecture for the first demo will look like that. One black pie, which are our clients, so in this case, the Angular application, talking to an orange pie, the oranges are the number APIs. One instance. So how are we going to develop that? We have several frameworks in the Java world, but also outside the Java world. There's Drop Wizard, Lagom. Even if they come from Scala, they have a Java implementation. Vertex, we also thought of doing some Vertex. Spring Boot, famous. We'll actually be using the microprofile, part of it, not all of it. So we have two microservices, and we will use the microprofile to develop them. So what is the microprofile? Well, the microprofile, if you follow the long history of Java EE that has been renamed Jakarta EE, there's plenty of specification in Java EE, and a team made of Red Hatters and Tommy Tribers and IBMers and whatever decided to take subsets of these specifications and create this microprofile. So the microprofile is JAX-RS of CDI and JSON-P. That's the basic to write microservices. And then they have extensions. They have implemented what was missing in Java EE to fit the microservice world. So the base is JAX-RS, CDI, and JSON-P. And then we need configuration. We'll actually be using configuration. Security, health check, fault tolerance, and more things are coming. Now the microprofile will be on 1.4 version very soon.
And there is a version 2.0
on the way.
Soon. Does anyone here use microprofile or heard about microprofile before? No one. Okay.
That's
yours.
Oh, thanks.
Yeah, I mean, and Spring Boot. So who's here using Spring Boot? Okay, so I guess that we need to change it for Spring Boot. I mean, if you look into the microprofile code, it's pretty much the same as Spring Boot. So as Antonio was saying, the microprofile project born as a way to actually move. As you know, like Java EE, if you're using Java EE, like all the specs were like super slow and they were painful to implement because there was like a lot of discussion. It was all about standards. Now microservices is anything about standards, right? Because there's like a huge amount of ways to do stuff, and everything moves super quickly, right? So all these companies came together to actually work in a fast way to give specs that actually move the microservices world forward. So that's why it came up with all of these specs. So it started with the CDI, JAX-RS, and JSON-P, and now all of these specs came out just in the last year, and there is like a few more in the pipeline. So we don't have over there, but there is like Open API for documentation, Open Tracing for like tracing your microservices calls. So all of that is being implemented by these companies called IBM, Red Hat, Tommy Tribe, Payara. Just recently, Pivotal, Oracle also joined the microprofile initiative. Fujitsu also there. We also like the London Java community. I'm not sure. Is there anyone? I mean, we're in London, but is anyone here from the London Java community? Okay, a couple of people. So even the London Java community is also part of the microprofile initiative, and some other jugs like SoJava in Brazil. So, I mean, we think that a lot of smart people are involved in there. So things are really moving forward in that regard.
But you won't see a lot of code. We will mostly be using JAX-RS and CDI, and the Netflix OSS thing, plus bits and pieces. So even we haven't used fully the microprofile just to show you that we can also integrate with other things. Okay, so the number API. Think of it, JAX-RS endpoint, and generates random numbers. So really, it's 5 lines of code total. So we just do an HTTP GET on an API, numbers/book. /book because we were thinking of doing CDs and other things, but we didn't. It's on port 8084. You'll see that This is hard-coded at the moment, but we'll have to change it. And we expose a Swagger contract, and that's quite important. So this is the number API. Not much. You do an HTTP GET. It returns text. It doesn't even return JSON. And it just math random. So it's a dummy number. But that's what's going to be used by the book API when you create a new book and you need an identifier. So this is the number API we will be deploying on those pies. It will be running on Wildfly Swarm. So the number API will run on Wildfly Swarm, and the book API will run on Tommy, just so we have different implementations. So do you know Wildfly Swarm? No, not a lot of people.
Couple of people, yeah.
Not a lot of people.
There are Spring Boot people.
It comes from Wildfly, JBoss. It actually was renamed last week. So it's open source. It's modular. So if you think of JBoss application server, you have a full application server, and you deploy a WAR file in it. Okay. Wildfly Swarm is the opposite. You take your code, and you take the modules that are needed, and you package that in a jar file. So for those of you who come from Spring Boot, it's kind of the same idea, is you have your code, you take the technical parts that you need, HTTP server, REST server, JAX-RS, etc., and you bundle that with your code inside a jar file, and this is an executable jar file. So that's Wildfly Swarm is. Think of it of a Spring Boot for Java EE. So it's modular. You have all these fractions. So security is a fraction. If you need it, you embed it or not. HTTP is a fraction. The CDI is a fraction. JPA is a fraction. Okay, so the idea is you have your code and you bundle the needed fractions with your code inside a jar file. And then what we will be doing is java.jar. So, okay, it creates a jar file and you just execute this jar file, just like Spring Boot. And yeah, so last week it was renamed by Thorntel. So that's the new name, and it's brand new because it was last week. So we are running on Thorntel. It's tough to say for a non-English speaker. So that's our number API, and in front of it we will be doing web app. So we use Angular. We use also Bootstrap because we are bad designers, so it was at least it can look kind of okay. And so we have Angular app running on port 8080 with Nginx. And the Angular app will invoke the number API. Simple demo. And in the middle, we're going to put something that we'll be using throughout the demos, a contract, an open API contract. So open API initiative comes from Swagger. If you are more comfortable with the name Swagger, that's where it comes from. So it's a specification about how to document your API. What can you call? Which verbs can you call? What are the parameters in? What are the parameters out? What are the status codes? So this contract is either written in JSON or YAML, and we will be using that as the contract between the front end and the back end, and we will generate some code out of this contract. We use Swagger. Swagger is the implementation. OpenAPI is the specification. So there's several ways to do it. Either you write JSON. You have different tools that allow you to write a contract. And for people who have been in the industry for a long time like me, think of it as a WSDL. So the contract, the WSDL contract for SOAP, the equivalent is the OpenAPI contract for REST. So either you take a JSON editor and you write JSON and you create the contract, or that's what we've done. We used Swagger annotation. So as you can see here, we took our number API REST point, and we have this annotation at the top called API, so that's the Swagger annotation. And at the bottom, at the generate book number, we have another one called API operation. So that allows you to create a Swagger contract, but with Java code, which is easier for us. So when you put put these annotations and you do a bit of magic with Maven, this is what we get. So this is the OpenAPI contract for the number API. So as you can see here, we have the description that we put on our annotation. We give it a name. This is the number API. This is the path, number API / API. And then what do you expose? Well, you have a numbers / book, and you can do an HTTP GET. And then you say, bits and pieces, it returns text, it can return a 200, it can also return a 4, 5, etc., etc. So we've put some annotations on the Java side. It generated an OpenAPI contract, and now we can go to the Swagger ecosystem that has IDs and whatever, but what we're interested in is Swagger Code Gen. We have this contract, let's generate code out of it. So that's what we did. We generated our client stubs. For several languages, we did that for Angular. So it generates TypeScript that we can add on our Angular app. So it's just one line. You give it the Swagger JSON, so the contract, and with one command line, it generates client stubs for anything. We will reuse that later because we have the book API written in Java that needs to talk to the number API, and we also created this client stub using Swagger Code Gen. So that's quite handy. If you do contract first, a question?
Just a question. So for WSDL in SOAP, typically the WSDL is exposing the URL in the microservice. Is that the same for the Swagger JSON or?
So the question was, in WSDL, we usually publish the WSDL within the microservice. So you point at a URL and you get the WSDL. Can you do the same for Swagger? Yes, that's what we did, and we will show you. So we have a URL. So that's also a nice way when you expose an API that will be consumed by someone else. You give it a URL. So that's what we'll be doing. And again, with the entire Swagger ecosystem, you'll see that it's quite easy and looks nice actually.
Yeah, let me add. So you can expose the YAML of the JSON file for this, but we're doing that as well. Now in this particular case, we also generate it offline. So then we can generate the code offline, so we don't have to start a server to go and grab the YAML file on a running server and then going to the compile again to generate the code again. So it was just easier to just generate the file offline and then generate the code on top of that. And then when you run the server, you have everything. So that's one of the reasons why we do it that way.
So this is the code that is generated for us. Good. So thanks to the Open API contract, this is what we have. This is TypeScript. This is what we'll have on the client side. So, you know, it generated code with a nice looking method name. Plus there's a bunch of if, you know. So all that is done automatically. So that's good.
Yeah. So let me just add that just recently came like the new version of OpenAPI a few months ago. So in here we're still using the old version. Now a new version came out with more details on the JSON and the YAML file. Swagger itself made the implementation working like only 1 month ago. So we thought it was like a little bit soon for us to migrate to that. But just for you guys to have an idea that there is already a new version that changes the annotations a little bit and generates a JSON file or YAML files a little bit different. But most of the tools are already making support to support both files, so it should work fine.
So the first thing you'll learn with microservices is CORS, cross-origin resource sharing. We have the Angular application running on one black Pi and the number API running on the orange Pi. Different origin will not work. That's, you know, specified on the HTTP, the W3C. CORS is built in, so you can't go from an origin to another one. So that's the first thing that you'll have to solve with microservices. The boundaries are different, so the browser will not let you go. From you are pointing to to origin A, and then it goes to origin B, not allowed. Because number API and Angular are on different machines. So the first thing to do is to solve CORS. Of course, in production, you have your network guys. Thanks for the network guys. That will do that for you in a very subtle way. You can say only server A can access server B. You know, you can go at this level of detail. Because we are doing JAX-RS, we could have also created a JAX-RS filter. But we decided to create a servlet filter because with cross origins, you have the problem not just for HTTP GETs, but also if you have an image. You know, you access one origin, and this one needs to, you know, upload an image. So that doesn't work. That's why we put it on a very low level, at the servlet level. So that looks like that. So the code that we will be showing works thanks to this servlet filter. Here, we just said we allow everything everywhere. So we allow every origin. We allow get, post, put, delete. We allow everything because we want to make the demo work. That's what I was saying. The network guys might tune that a little bit better, saying server A is only allowed to server B, but only HTTP gets, not HTTP puts. So you can go at this level of detail. We didn't. We just we allow everything everywhere. So yeah, if our code works, thanks to this servlet filter that solves the CORS problem. I'm going to do this demo locally, and then we will push it to the Pis. Okay? So I've done a SSH on them. So I'm going to demo 1, and I'm going to show you the service, just so you can see that it's dead simple. It's a bit messy because we have some Java code, a couple of lines. We have a few annotations. JAX-RS annotations, but also OpenAPI annotations. And because this is the code that you see in the slide, we have ASCII docs everywhere. So sorry, it's a bit messy, but I promise it's not 53 lines of code, it's about 10 at the very max. So what's important here is we have a path, so we have to go to /numbers, and we do a HTTP GET on /book, and that will return a random number. It's a web application, so if you look at the POM XML, you know, there's a WAR file, something. But as I said, the magic, here I have Wildfly Swarm on my POM XML, and the Wildfly Swarm plugin will let Maven create the WAR file, because this is just a web app, but then it will put the needed fractions into the jar file. So Wildfly will create a big jar file with a WAR inside and the needed fractions. So if I go to the command line, back to, is it, wait a second, I'm gonna do that. Is it better at the top? It's better like that? Yeah, big enough? So if I go to demo 1, number API, let's do a Maven clean install, skip the test. So it's cleaning my target, compiling my code. Here you see there's the WAR plugin. So the Maven WAR plugin created a WAR. But then, after the Maven WAR plugin, we have the Wildfly Swarm plugin that does a package and goes and scans from fractions, blah, 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 blah. At the end of the day, if you look what's inside the target, you have a WAR file of 70 Ks, the good old WAR file that we take and deploy into JBoss, WebSphere, or whatever. But what's important for us, it's these 65 megabytes executable jar. So that's Wildfly Swarm. It took the WAR file, put inside a jar with all the needed fractions, and now I can go Java jar. And for those of you who know JBoss, you will see some logs that will look like JBoss. Wildfly Swarm is running. So now it's, oh no, that's the book API, sorry. So here I'm on my local machine, 8084, /number API / blah, blah, blah. And as you can see, it generates a number, nothing fancy. But now, I also need the web application. So, so here, you know, as I said, we are using Angular, so I just do a ng-serve. Oh, yeah, I've updated last night.
Probably that's not a good idea.
I'm sure it's going to work. Yeah, okay. So I'm on localhost 42. So if I go to localhost, whoops. Angular. So this is just invoking the same API. And to answer your question, here is the Swagger contract. So thanks to the Swagger ecosystem, I didn't have to write all that. So it takes the Swagger contract. It discovered there's a get on number book. And I can actually try it out. So I can execute it. And I don't know why my CSS is broken, like most of the CSS. So here is the book. So if I execute it again, it will change. So that's the Swagger. Also comes with Swagger UI, which is a very nice way to visualize a Swagger contract. And you can give that URL here to your business partners, and they can consume it and generate whatever code they need. Any question for this very simple demo? Back end, front end? Yep.
There you go.
So is that Swagger JSON just generated from that one annotation from Java?
Yep.
Yeah.
Okay.
So this very complex JSON, that if you are doing contract first, you will write that. And actually, Swagger has this tool called Swagger Hub. Very, very nice. It allows a team to create a JSON. So you can have the front-end guys and the back-end guys, and they all agree on a format. And then you can create your Java and TypeScript. We decided to generate that out of the Java. So we went, instead of going contract first, we went code first. That generated this Swagger, and thanks to that, it generated the TypeScript, and later the Feign client.
Can you show the code again?
Which code?
The one that has the annotations.
Yeah, it's really messy, but what I can do is go to demo 3 and show you the code without the same code, but without the annotations, number APIs. Yep, here it's better. So here, if you look at the code, this is just a CDI annotation saying I have one instance. This is JAX-RS saying this is the path and it produced text. And then you have, if you look at the package, you have here the Swagger annotations. And here, generating all sorts of numbers. You have it somewhere here. Yeah. So it just allows you to create the Swagger out of the Java code.
Yeah. So to add, show the code again, please. Yeah. So even though we're using like some custom annotations here from Swagger, most of them are just to enhance, for instance, documentation. So even if you don't use API or API operation,
you can
Swagger,
take that out.
Yeah, Swagger will just generate the contract just by looking into the JAX-RS annotations or the produce and consume annotations that you probably also use on your Spring Boot application. So you still need the Swagger dependency to generate the Swagger contract, but you don't really need to use the Swagger annotations. Those are there just to enhance the Swagger contract you're going to generate, especially by adding documentation, or even, for instance, maybe we can show the book just like a little bit.
What's important here is because we return a response.
Yeah.
If you want, you can say that the response is a string or the response is an object. So, as you're saying, those API annotation are just there to add more information.
Mm-hmm.
But if you look, this is plain JAX-RS. I'm saying I'm producing text. And if you look here, Swagger is clever enough to say, he is producing text, so he's saying text plain.
And
If you would generate the contract first, can you generate the JAX-RS endpoint from?
Yeah, so the question is, if you do contract first, can you generate that? And the answer is yes. Swagger Code Gen, if you go to the Swagger Code Gen website, you can generate client stubs or server stubs. So you could actually have created that. And to be honest, we are Java guys, and I love that. But when you work with a team of front-end guys, etc., I'm doing more and more contract first, to be honest. So we use Docker Hub. And at the beginning, I went, me alive, I will never write a line of JSON. I will write Java code. But at the end of the day, just a contract between microservices and also the back end and the front end. And the front end guys have a say, and you have a say. And I'm doing more and more contract first. And Swagger Hub is actually a nice tool. And after with this contract, you can generate the JAX-RS or even Spring Boot code. Yeah, another question?
Yeah, am I right that you have this course problem only when you're running the microservices locally? Because in the production, as far as I understand, you put them behind the same reverse.
Yeah, so the question is, you have the course problem because you are running it locally? The answer is no. We'll have the same problem here. What you have is a network engineer that soothes your pain.
Yeah, but if you put them behind the same reverse proxy...
Yeah.
That's
exactly.
the reverse proxy.
That's the reverse proxy.
That does that.
Yeah. Just as a side note, all you are seeing, all what you'll be seeing, all that, all this, the hardest thing was the bloody router. We spent huge amount of time just configuring that. Painful. So that's because you have a network guy that knows how to configure the router. We don't.
Yeah.
Roberto, that's your turn.
Okay, thank you, Antonio.
Because that was local.
Yeah.
I'm a developer. I do that on the Mac. Now I give it to the ops.
Thank you. Okay, let me actually change this.
Yep.
Okay, awesome. So now I'm going to try to replicate what Antonio did on his local host on these pies over here. So it doesn't seem to be very difficult. I mean, it was just a simple jar and a simple web app. So it shouldn't be that hard to do it over here. But first I'm going to explain a little bit with more detail the setup that we have here with the pies. So as you've seen already, we have all these bunch of Raspberry Pis. All of them are running this IPOS. It's something very interesting. I'll give a little bit of detail. We do everything with Docker. We pack so what we're going to do is I'm going to pick up that jar file, I'm going to pack it in a Docker container, then I'm going to push it to the Raspberry Pi, I'm going to run the Docker image over there. For that reason, I'm going to use something called the local Docker registry. I'll give you more detail about that as well. And then we use Ansible to push those Docker images to the Pis and to the Docker registry to actually move commands on the Pis. I'm going to show a couple of examples on that as well. And the Pis also support Docker Swarm, so you can definitely use Docker Swarm on the Pis as well. In this particular case, we wanted to control manually what we wanted to deploy, for demo purposes. But you should definitely use Docker Swarm if you want on the Pis as well. So for the Raspberry Pis, what we're running actually here is the latest version of the Raspberry Pi, the version 3. It's somehow a very interesting machine. It's like $20, $25. And it has a somehow good capability, so we're able to run Java on that. We're able to run a lot of stuff in that, and we cannot really complain. Sometimes they're a little bit slow on the start, but most of the time it works just fine. So the IPOS, so this IPOS is something that some guys, enthusiasts on the Pis, came up with. It's based on Raspberry, and basically it's just a really, really small image of the distribution of Raspberry that it can run on the Pi, which already packs Docker inside. So it's like 50 meg or 60 meg image that you just flash on an SD card, put it on the Pi, and then you can just start up the Pi, and then you can just run Docker on that. Has anyone heard about that before? Okay, there was a gentleman over there. Awesome. Did you enjoy that?
Yeah, it's pretty good.
Oh, awesome. So one of the things that I love with this setup is actually I do most of my development on this setup, right? Who here runs stuff on the cloud? Yeah, most of you guys. I don't run anything on the cloud. I run stuff on my Pis. You know why? How much do you guys pay for running stuff on the cloud? $1,000 a month? $2,000 a month? $5K? $10K? I bought this for $500.
Micro profile, micro bill.
Exactly. This setup over here well, I mean, we have two setups, but like all these setups that you have, like 12 pies, switches, routers, like cables, sockets, it costs like 500 euros or $500. It's even less than euros. And it's yours forever. So you can pretty much run whatever you want over there. And it's, like, I'll tell you this story. So in my company, in part of our project, I was developing a load balancing feature. And as you probably figure out, the load balancing feature is super hard to test. If you're running stuff on the cloud, and then you want to like test failovers or see when the load balancing goes to one place to another, how do you do that? You have to go there, kill the machine, and try to figure out what the hell happened. I can just over here and just unplug cables and see what's going on, right? And I can just leave it running for like the entire night, and it's just going to cost me a few bucks of electricity. That's going to cost me like 1K or 2K on running stuff on EC2. So I really advise you, if you guys at least try to buy one. It's not really expensive, just one. Play with it a little bit and see if you like it to do like some kind of development. And then if you're happy with it, then buy more, stack a little more, and play a little more. So for Docker, everything we're going to pack, so the Angular app is going to pack into a Docker image. The number API is going to pack into the Docker image. And then we're going to run the Angular app and the number API app into two separate Raspberry Pis. To actually build those Docker images, we're going to use Maven Fabricate plugin. So it basically just pick the jar that we have. We'll just start with a Docker image, Docker image that has Java. Just slap the jar in there. Then we can just run the java-jar and the jar name as Antonio did on his local box, but instead it's going to be on the Docker container. So one interesting thing about this is since the Pis use Raspberry, you usually require a separate image to run on the Raspberry Pi. So when you're building the images, you have to run one, for instance, to run on the Mac, and then you have to start with Raspberry for the Pi. So we have to run two separate images because of the base image that you start with. So one from Raspberry, other for regular Unix. But other than that, the images are exactly the same. So only the base image changes. Now, Docker registry. So Docker registries, we also run a local Docker registry. So it's exactly the same as Docker Hub, so it doesn't have like all the fancy UI stuff. And we do that because we want to be fast. And we don't want to push stuff to Docker Hub and then grab stuff to Docker Hub. So basically it will be, okay, I'm developing my stuff over here, now I'm going to push this to the cloud, and I'm going to grab this to the cloud and then put it here again. It's like a waste, right? So I run this locally, so I don't, and also cool for demos. As you were explaining in the beginning, we were having some issues with the cable. We didn't have internet connection. So in here, I'm also stable enough that I don't really require internet connection for all of this, except for synchronizing the time date of the Pis. But that's the general idea. We don't use Docker Hub. It's too slow and unreliable when you're like on conferences or on Wi-Fi networks. So it's just easier to have like this local Docker registry where you just push locally. Everything is just local network calls to like push data and retrieve data, so it's much faster. And we run this on the port 5000. I'll show you a little detail. So let's build the same project that Antonio did, but by generating these Docker images. So I have here. Are you guys able to see this, or shall I increase this a little bit? Okay. So in here, I'm just going to run pretty much the same Maven command that Antonio did. Just going to remove this little piece for now. And I'm just adding the Docker build and Docker push. You can definitely add those as part of your build, but for convenience, we just add them as just using the commands on the plugin separate. So we don't waste time to generate the Docker images every time we want to do a build. So we explicitly say we want to build a Docker image now and want to push it to the Docker registry now. So I'm gonna just run this very quick. So now building the project, building the Angular app and the Number API app. So that's Wildfly Swarm running. Now I'm generating the Docker image. So this Docker image is for, it's a Docker image for Alpine Java that runs on the Pi. And the other Docker image is actually the OpenJDK default one that's to run on my local box. But other than that, they are exactly the same. And now what I'm seeing over here is this image is being pushed to my local Docker registry. So the idea here is now I have this local Docker registry, I push my Docker image over there, and then when I want to put them on the Pis, I'll just say Pi, go and grab the Docker image that I put on my local Docker registry, so I don't have to go to Docker Hub. So one interesting thing about the Alpine and the OpenJDK image is, as you probably, so this is like an ARM architecture, right? So if you try to run OpenJDK directly over there, it's going to be painfully slow, especially because floating point implementation on the OpenJDK. So there is like an Oracle version that specifically built to run on the ARM architecture that just like proper implementation to run on the ARM architecture. And for you guys to have an idea, so a Tommy server to start up with the OpenJDK. So you're able to run OpenJDK on the Pi if you want, but it takes like 10 minutes to start up. If you run the Oracle specific JDK to run on this architecture, it takes like 1 minute. So it's like a huge amount of time difference over there. Excuse me. So now my images are built. They are pushed to the registry. So I actually running the registry on my Mac as well. So I'm going to do here docker ps -- all. And then you'll see there is some image over here called Docker Registry from the image registry version 2. And that's something that Docker Hub gives you for you guys to use. So it's free. You can use it. It's super simple. There is really no UI involved in that. For you guys to have an idea, so this is Docker registry that I have, and basically you're just able to do like REST calls and see. Oh, sorry, sir. What's the question?
Yeah, just a small question about the registry.
Mm-hmm.
Is there any particular reason why you use this registry? As far as I know, you could just push the tarballs into the into the Raspberry Pis, for example.
Mm-hmm.
You can just use the tarballs and push them using Ansible from your local images, not from the registry.
Well, the idea is that
can you repeat the question?
Oh,
so
yes,
people
sorry.
can
So the question was why I was using the Docker registry instead of like pushing tarballs directly with the image itself from here. So the idea that we came up with the Docker registry was it was just easier to use the Docker image or the Docker container plugins from Ansible, which basically just go over there and you just say I want to pull from this image, I want to like start, stop, whatever. And also because sometimes we have one thing that I didn't detail a little bit is that the guys that wrote or provide the iPriot OS also have a lot of images that are already specific to run on the Raspberry Pi. So for instance, they have images to run Postgres, Consul, Nginx. They have like images to run like 30 or 50 other softwares, and they have that on Docker Hub. So for those particular cases, I really need to go to Docker Hub to grab those. So what I do is I'll just go to Docker Hub, put it on my Docker registry, so I'm all local all the time. And here basically you'll just see, so you can do like local Docker registry on those ports and do like underscore catalog. Then we'll see what the repositories are over here. So it doesn't have any fancy UI, just something like this. And now, so now I have my Docker images built from the app. I have them on my Docker registry, but I still need to push them to the Pis. So how do I do that? I use Ansible So who here knows about Ansible? Okay, a lot of people. So for you guys that don't know what Ansible is, so Ansible is just like a way that you can use to control a bunch of servers. So it has like, it's written in, I believe, in Python, but you don't have to use Python at all. Basically, it just has like a set of plugins. You have like some YAML files. You can just say, I want to use these plugins, and you will say what are the servers you want to connect with, and then you can run commands on those servers in a super easy way. So to give you an example, I can ping all my pies with just a single command, so I don't have to go and SSH to all the pies and do that. And I can deploy Docker image to all the pies. And then there is something called playbooks on Ansible, which basically is just a list of tasks that you can add, and then that will be run in the order that you specify. To say, I want to copy this image over there and run that image on that pie, and I now want to do this on that other pie. So it's just like an easy scripting way, instead of using like a bash or something else that you could use. So this is the playbook for our service. So you start with something called host, and the host, let me give you an example as well. So this is a host files on Ansible. So the host files basically is just like a generic file that you set up some configuration. So in here we just say, this is my Ansible user, this is my Ansible SSH pass, and these will be the credentials that Ansible will use to connect to all the servers. And these ones over here are actually the host names of the pies. And if you notice, there is like something in square brackets before that, and that allows you to create a group of machines. And instead, when you run a command, you're going to say, I want to run this command on, for instance, pipeline 01. But you can also say, I want to run this command on clients. And we'll go on the clients list, and we'll just run all the commands in pipeline 1, 2, or 3. So then we came up with these. So we have like a set for clients, set for servers, set for databases, and so on and so forth. Now, so coming back to the playbook that we have, so there are like a couple of generic configuration over here, so we're not going to bother about that at this time. And what we're just doing is we're using the Docker container plugin for Ansible, and we'll just say, I want to, this is the number API name for my Docker container. And the way that I say to actually pick up my image from my Docker registry is just I pass in the image name, I pass in here where my Docker registry is running. So in the occasion that I don't really have this particular information over here, the Docker container plugin will try to go to Docker Hub. But since I actually hard-coded here the host of the Docker registry, will just try to pick up the image from here. And then there is just like usual Docker stuff, expose ports, pull the image, and in here I'll just say, even though I'm running these on all the services group, I'll just say, but I want only to run these on Pygram server 1. So there's also another way to do that. Okay, so now coming again. Okay, slides. So let me just run a couple of Ansible commands. So let's hope that this works. I'm going to pray to the demo gods that these. So help me out.
Is it big enough? John,
No,
make
just
it
gonna-
bigger?
Yeah, there you go.
Oh, plus green and black, it's...
Okay, well, not sure if I'm able to change this color, but but basically green is good because it will just went to all the pies, ping them, and actually, like if I'll disconnect the cable,
The demo gods.
maybe that's not a good idea.
Okay, do it.
So you disconnect the cable, you should actually see a red one. Might take some time, but all green. No, it's not finishing up. Come on, red. I think I broke it.
I've told you not to do that.
I know, but you know, I like to live on the edge. Yeah, it's just like the ping timeout. La la la, come on. Well, but you see that the command's not even finishing, so let's see a little while. Okay, so when I went to deploy those images into the pies, I would just like use this Ansible playbook and say Ansible deploy YAML file, and I will just say I'll point out to the host file to run the task that I show you. So on Ansible, you can just run stuff like haddock, just with command directly on the command line, or you can just write those files and then can run the file to have all the commands. So yeah, now we have like an available over there, unreachable actually. So let's plug that in again. Okay, so now I'm going to run the Ansible playbook with deploy. So now it's running. It's going to pick up that file that I just showed you over here, and it's just going to run that operation. So deploying the number API. There's also a similar one to just deploy the Angular app. That's also running. But I don't have it over there. So now just connecting the pies, pulling the Docker images that I just built, starting the containers, and when it's done, it's going to just output the result. So it shouldn't take that long, hopefully. I'm just going to do that once, then for the other demos, I'll just have them done when Antonio is speaking, so there is not that much boring for you guys, but just doing this the first time so you can see it, how that is done.
And you can see that it takes a bit of time.
Yeah. Most of it is because the pies are just starting up. So now one of the pies was updated, at least with all this yellow stuff happening. Okay. So now the Ansible command is finished. So now we see like 2 yellow ones. Those are the ones that actually were updated. So I updated PyClient 01. That's the one that I'm running the Angular app. And I updated PyGram server 1. That's the one that I'm running the number API app. And the other ones, well, they're just part of the build, but I haven't done any operations on them, so there is no report that they were changed.
So is it working now?
Hopefully. So now, let's go here to, these are the slides. Now here I'm going to my store. So that was the same store that Antonio show you in the local host. Okay, now it seems to be working something over here. Let me increase this. So it's like store demo 1. I'm not sure if you guys are able to see this, but it's actually running on the PyClient 01 host name. And now I should have exactly the same things that Antonio showed you, like the numbers book number. So this is probably going to take, okay, actually it's already running. So now I'm able to generate numbers here as well, like Antonio was doing, but now it's running on the pies. So do you guys believe me that I'm running these over here? Does anyone doubt about that?
No, we won't be cheating.
Well, but I think that they don't really believe me. So I'm going to just unplug some cables over here.
God, are you mad?
I know, I like to live on the edge. So I'm going to try to generate a couple of book numbers, and now you'll see I'll still have one over there, but this probably is not really that big. But you see, like, the requests over there are pending, so there's nothing actually reaching the book number API because it's disconnected. I'm not going to do a curl, but now if I plug these guys back in again, it should start giving some book numbers. So those failed, but now the service returns. So now, do you guys believe that I'm actually running these over there? Right? Try to do that with EC2, right? Okay, so
your demo's finished?
I think so. Let me see what I have over here.
Yep.
Yeah.
Okay.
And so the next thing is we're going to start now adding stuff on top of that, and we're going to start adding one more microservice. Okay, let's.
So it looks like the ops guys have managed to put that in production, but that was just the number API. Now we need to add a book API that will talk to the other. So we have one number API, we need a book API. Book API invokes number API when we create a new book. We have an Angular client, and we're going to be using 3 pies. How do we deploy and make it run? We will see that. So the architecture will look something like that. We still have the Angular app, but this time the Angular app will call the book API, and once we create a book, it will need a number. So that's what we're going to do. Cores all over, again, so we fix that. So now we have these, microservices that need to talk to each other, because it's fine when you have a web app that talks to different microservices, but in reality is the web app invokes microservices that they invoke each other. It's this spaghetti mess. So now we need one microservice to talk to another in a Java world. And here comes a brand new world, and you have to think about it when doing microservices. First question is synchronous or asynchronous. Very important. Asynchronous, loose coupling, perfect. Very complex to handle. You need a kind of Kafka or messaging or event bus or something like that. So it brings you benefits, but also some drawbacks. In our case, we stay synchronous, and we are using REST. So we will only use HTTP calls and synchronous ones. When I create a book, I want the number now. How do we create this channel between those 2 microservices? Well, it's just HTTP, so we can do it by hand. There's an HTTP client in Commons Apache, which is very good. JAX-RS has also a client API. We could have used that because we do JAX-RS, but actually we will be using Netflix Feign. And later on, you'll understand why it was a good choice. So Feign, I don't know if you know about it or not, but it's just a Java HTTP client. So it's inspired by all these tools that we all know, but Netflix decided to do one of their own, and you'll see later why. So the idea is, of course, I can do it by hand, but you know that if I do a HTTP call by hand, it's a lot of lines of code to just do an HTTP call. Plus, we want some goodies. So yeah, we could have used Jersey or REST-easy or CXF, but we decided to use Feign. So the book API is also a JAX-RS endpoint. It does CRUD operations on books, so it goes a little bit further than just the number API. We actually use a database and JPA, so just to tell you that it's starting to be a bit more complex than our number API. And we can do get, post, put, and delete. That's why in the Kibana dashboard at the beginning, you could see different, deleting books and creating books, because we do get, post, put, and delete on /books. And it listens on a different port, because it's important for me on my local machine. So this is the book API, nothing special. Again, I find here my JAX-RS annotation, the Swagger, the Open API, because I'm documenting. What's interesting is here. It's remember that my book API needs the number. I'm in the Java world, so I want to inject this number API. I know it's somewhere else, but I'm going to generate a stub, and I'm going to inject this stub. So on my Java code, I just inject a number API. We will see where it comes from. And when I create the book, that's the important bit, delete book, consume, something's wrong on my slide, sorry. I'll go back to the code because I can see it's wrong. So when I create a book, I need an ISBN number. And this ISBN number comes from the number API. As you can see, it's quite elegant because it's one line of code. But in the meantime, it has crossed, the network and invoked a different service. But for me, it just returns a string, and then I can create a book and persist it on database. This book API will be running on Tommy, not on Whitefly Swarm. So for those of you who don't know Tommy, it's out of Tomcat. It comes from the Apache world, and it adds Java EE here capabilities on top of Tomcat. It's open source and supported by those guys who do an amazing job. And it's the same idea of Spring Boot, Wildfly Swarm, etc., etc. It just takes your code, bundles Tommy inside, and we have an executable jar. Thanks. Remember the good old contract, the number API contract. On demo 1, we created TypeScript. Well, guess what? There's also an extension to create a Feign client. So Swagger CodeGen creates a lot of things. So here, we could have created a JAX-RS client, but just with this Feign here, it will create a Feign client. What does it look like? Well, this is our interface that we inject. And as you can see here, I have some magic. That's the Feign magic, saying please do a HTTP GET on numbers/books that will be somewhere, and returns text plain. So this is generated by Swagger CodeGen, and it's a Feign client. Then Feign needs a builder, so it can configure different things, and that's it. Then, because we are in the CDI world, we produce that, but we could have used it out of the box. That's why we can inject. Okay, so in the book resource, to do something complex like invoking a separate microservices, is just actually injecting an interface, and Feign will do the rest. Demo locally. So I'm the developer. So here is the number API, java.jar, Wildfly Swarm. Okay. So here I have the number API. Here I have the book API, Tommy, but again, java.jar. Here we go. And we still have an Angular application. So ngserve. So here I have book, number, and the front end always takes longer. It's amazing.
People complain about Maven.
Yeah, wow. Here we go. So this is my new application. It still has the number. It's working. I can show you the logs. The logs are moving. Anyway. And here, when I create a book, so I have one book in the database. And when I create one book, matrix. No ISBN, and when I click save, I have an ISBN number. Okay, so I clicked save, it did an HTTP post on the book API. The book API invokes the number API, returns an ISBN number, and does a persist. So, there's an API here. So now I have two books, and here I have the number API. So, I'm a developer. It looks okay. Works on my machine. So I give it back to the ops. Roberto.
Okay.
Can you deploy that for me?
Let's give it a try.
Now that's when the dev goes back home, leaves the production. It's late at night.
So
I'm having a pint with my friends.
Yeah, go. And
I'm a developer.
And then I'm like there on the office Friday evening. Well, office at home, right? But Friday evening working till 1 a.m. while other guys are having fun at the pub drinking pints.
We call that the DevOps.
Yeah. Anyway, I already been for the trouble of running all the Maven commands and Ansible commands, so you don't have to have that boring part. So you have to trust me, I already deployed the book API and the number API over there, so now you can see here my Ansible stuff has like 3 yellow updates. So now I'm gonna go, oops, not that one. So now I'm gonna go to our store again. So now we are on demo 2, and if I try to invoke book numbers, I still have the book numbers. Awesome.
The developer did a good job.
Yeah. And now I'm going to my books. So let me try to create a new book. So title, I don't know, doesn't matter. Oh, something showed up over there. So I want to also write a book like Antonio, maybe 2020, and a drama. So actually, we already have a book over there. Oh, what happened over there? So it didn't work.
No, it works on my machine.
It did?
Yeah.
Well, I had a 500.
No,
what's happening over here? Let me try to see. Oh, we have some exceptions.
No, can't be.
Well, I don't. I mean, there is something over here. Let me try to SSH into the Pi and see what's happening. So
SSH, which Pi? Which one?
Well, actually, know that I actually deploy the PyGram loads balancer. It's not really like the awesome name, but that's what we have. Okay, so basically I SSH over there, so I can do like a Docker logs, book API to see what's happening. I get the connection refused. Let's see, localhost 8084. Antonio, we're not running on localhost. We're running on microservice. So my book number is running on one host, and the number API is running on another host.
Works on my machine. That's your problem.
Did you hard code localhost?
Yes, of course. It's
Come on, man. It's not running over here.
Well, the first thing you realize is monitoring. Here it's okay because we have one Pi and we could spot it. But quickly you'll understand that you have all these microservices all over, and if you don't monitor, you can't ask your ops guys to SSH every server. So lesson learned after the cable and the date and time is never trust a developer who tells you it works on his machine. And second is monitoring. It's something you have to put very, very, very early stage. So we have several microservices running on several Pis. Something goes wrong. That was an easy catch, but something goes wrong. How do we monitor them? So the architecture is simple, but still, at this stage, it's better to put monitoring now, because later things will be difficult. So as we said, we put ELK, because that's what we're going to use, on our Mac, because it takes a lot of memory and process power, so we couldn't put that on a Pi. So that's why ELK is on our Mac. It could have been on a Pi. So actually, logs are being pushed to our Mac. So the idea is to have a central monitoring system. In our case, there's plenty of things that you can do. In our case, we're just centralizing logs thanks to ELK because it's easier to visualize and you can spot where the problem is. So several nodes log into one single place. Of course, this becomes a single point of failure. So when you do ELK, of course, you need a distributed logging system. So, again, you have to duplicate it, be available. So here we just run one instance, but in real life, you have to have that on several nodes. So how do you do that? Again, you can do it by hand, but don't. Syslog, it's a good old one. There's also Fluentd that is quite famous. Splunk, also, it's a bit expensive, but Flume. Logmatic, blah, blah, blah. We choose ELK. Who uses ELK? Because it's quite common. Well, okay.
A few people.
Yeah, okay, a few. So the idea is ELK, the L stands for Logstash. So Logstash will centralize, transform, and stash your data. Processes in a pipeline. Our pipeline is quite easy, but you can have complex pipeline that transform data, etc., etc. If you have logs, different formats, you need to transform them. Logstash can ingest data from multiple sources. For us, it's easy, log files, but it can come from different sources. So Logstash will take the logs of the wildfly swarm and Tommy. And we push that into Elasticsearch. Elasticsearch, we will show you, allows us to search. So where is the error? We have a problem in production. How can we find it? So we can search for it. And again, Elasticsearch can take data from Logstash, but others too. In our case, we use Logstash. And at the end of the day, we want to display that on a nice board. That's on a nice dashboard, sorry. That's what you saw at the very beginning. It's called Kibana. So that lets you visualize your data in a fancier way. And also have interactions. So you can zoom in, you can change the date and time. And then Roberto, you had to use Gelf. Explain us what Gelf is.
Okay. So Gelf is just like called like Graylog external extended log format. So the idea with Gelf is just a plugin that you can add into your Docker container. That's basically Logstash already is a plugin for Gelf, and then you can plug in Gelf on the Docker image as well that you're running. So Gelf already allows you to when you're extracting logs to already provide like a JSON format of a structured log. So it includes like the message, includes the host name where the log is coming from, date, time, IP addresses, and a couple of other information. So it's just very simple to set up. You don't really require to provide that information yourself. So Gelf already does that for you. So it's like one of the alternatives that you can use. And of course, you can also include other information, that JSON payload that's sent to the server to Logstash. So in here we also have the Logstash conf. So we basically setting up Gelf is just like adding the Gelf plugin over there, and then there is setup where you can just actually parse the log, grab little bits of information on the log, and then parse it as a structured data. For the people that know ELK, this is really important. So because when you have these parsed data as different fields, then you can also search for them directly or actually build dashboards with that. So one of the things that we actually do is on the log sometimes we return a status code. So we built also something that parses the status code. So we have the status code in just a field. Then you can use the status code to build reports and dashboards around that. Yeah,
we'll show you that in Kibana.
Yeah, then for basically then setting up Gelf on Docker Compose is just like setting up the logging and putting the driver for Gelf. So we ended up picking that because it was the easiest way to set up logging from Docker to Logstash and Kibana.
Do you want to do the demo then?
Let's see. I think I was having a couple of troubles over here, of course.
Change screens if you...
yeah. Let me see if I'm... okay. I think that was the issue. Give me a sec.
Oh yeah, we will. Next. Yep.
Okay. I think
the last demo before coffee. Oh, maybe not. No, you're gonna. have an extra demo, so
Yeah.
you feel pain of microservices.
So again, we have our store. Nothing really changes on the app side. So we didn't do
So
any.
it still doesn't work.
Still doesn't work. We're still able to retrieve book numbers, right? If I try to go and create a book, so let's do it like something simple, and hit save, I still get the 500. If I go over here, I'll still get the same exception. But now all the logs that are being generated are being collected into Elasticsearch and Kibana and Logstash. So I don't really have to go manually and SSH into all boxes to see the logs. So everything is being centralized over there. So now if I go to my Kibana dashboard, I have now, these are all the logs that are being collected. So if I come over here and, for instance, I'll say search for an exception, then I'll find exceptions in the logs. And now I can see that now the time is 11:15. I have like a log over here of 11:14, an exception. I can just expand this a little bit. And now I can see the exception that actually happened on my server. Then I'll see, okay, connection refused, executing the number API call on localhost. So now I'm able to see what happened. And this is a little bit small, sorry about that. And that's better. And now I can also see that, okay, these actually came from this host, Pygram load balancer, and the container name is book API. So all this information that's being generated over here is coming from that Gulf driver plugin for generating logs, which adds all this information to the log message. So now I can, of course, come over here and just say I want to search stuff from Pygram load balancer, and I can see all the logs that came from that server, right? So now just expand, you'll see are all the logs coming from this host. So it's something useful. You just centralize all the logs, and then you're able to search for them and see them into a central place. It's something that's mandatory when you have all these pies. You're not just going to go manually into all the pies and SSH all of them to look into the logs.
But we won't go for coffee break now, because there's one thing that I hate is to leave you with a demo that doesn't work. So let's make it work before going to coffee break. Okay,
I agree.
Can you switch?
Yeah.
Okay, so what is the problem? Now, thanks to the monitoring, we saw that easily that there was a problem, that the developer had coded local host in this code, bad.
Antonio?
So now the idea is configuring. We need to change that. So as a developer, I still want to use localhost, but then you have to push this code to test environment, QA environment, staging environment, production. Things change, not just your local host, but the username, password of the database, etc., etc. So we have hard-coded things. We have several environments where these environments could change. So we need to configure the host depending on the environment. So the architecture will not change. It's just the previous demo that will work. So we need to configure parts of the application. Also think of business configuration too. The VAT rate, if you have an application that needs to be deployed in different countries, how would you handle different VAT rates or currencies? In our case, it's a technical config, but the problem is the same. I need to change things depending on the country, depending on the environment, depending on different things. How do I do that? Again, there's plenty of frameworks in the Java world to do that. Environment variables, that's what's getting trend again. It's you start your environment with a set of variables. In this way, the ops guys can just change that and push your code to different environments. Property files, either in XML, JSON, YAML database, you could also. JNDI, if you come from the good old Java EE, JNDI, that was the purpose of Java of JNDI at the beginning. Spring config, if you come from the Spring world, and the microprofile as also a configuration mechanism. That's what we will be using. Oh, by the way, we use Consul. We will use Consul later. Consul also can be used for that, to push configuration. So the idea of this configuration, and again, for those of you who know Spring Config, is the same idea. We can have different configuration levels. We can have different files that change depending on the environment and so on. So the same property can be defined in multiple files, and you go, now take this file, or now the other, or merge the two and do things like that. Because some data might change at startup, but sometimes also you need a configuration that change at runtime, so that's a bit more tricky. But you can do that with microprofile configuration as well as Spring Config. So this is how it works. Remember our Feign client here that allows the book API to invoke the number API. Instead of this hard-coded localhost, we introduce an environment variable. But as a developer, I'm quite happy to use localhost, so I can leave it as a default. And then I have this API config, and I said, please get the value of the host at this variable number API host. So if I don't set it up, it's good. I'm on localhost, so it's good for development, but you will see that this number API host will now appear on our Docker files. So thanks to the config API, if the number API host variable is set, it will override and sets the base host, and the base host, it's what's used with Feign. So Feign will create a client either pointing at localhost or something else if you override it. Okay, so that's the only code that will change in our demo. And as I said, now on the book API, the only thing that we need to do is that. So on developers' machine, it works fine. With the Docker file, either locally or on the pies, it's just a matter of changing the variable. Demo before coffee?
Let's try. Okay. Okay, again, I already run the Ansible scripts to push these changes to my pies. Again, we haven't done a lot of things. We didn't introduce new services. There are still the same number, book API and Angular app running, just with the configuration change. So now I'm going to go here to my store again. So now I'm on demo 4. So now I'm going to try to create a book again. Awesome book. Myself. 2020. Drama. And yay!
Come on!
Come on, man. We took like 1.5 hours. No, 2 hours. 2 hours just to do this, man. That's
okay,
crazy.
so let's have a coffee break. So it looks like it's 30 minutes. So let's be back at 50. Okay, 50.
We hope that you'll get back.
So that's 20. Yeah, hope. And then we will go to registry, security, load balancing, and I promise at the end, if you come back, we will burn one Raspberry Pi and it will keep on working. Won't we?
Yeah.
Burn a Raspberry Pi?
Yeah, we can do that.
The red one, maybe? Hello, people. Welcome back. So we had a 30 minutes break. And while I was having a coffee, my friend was doing, he can't remember what. And now his pies do not work anymore. So while I'm talking, hopefully you will try to fix it.
Hopefully.
Otherwise, see, that's always the DevOps thing. You know, you have coffee, you type code, you go to conferences, and they do the hard job. So we don't know why it's not working anymore. But well, I still have my cluster anyway. But
Redundancy.
Redundancy. So we have a little issue in there. Hopefully, it's gonna be okay. So we had one microservice, two microservices talking to each other. We saw that if you don't monitor things, you get a little bit lost on your SSH. And when you move things around, you need configuration. And that's, the very, very basic things that you need when doing microservices. Now there's another very basic thing that you need. Until now it's a must-have. At the end we'll have a few nice-to-have, but all this is must-have. You must have configuration. You must have monitoring. And monitoring can be very, very expensive. Well, there's another must-have. It's registry. So now we have two microservices, the book API and the number API. But they can be deployed on any Pi. So, how do they know who is where? At the moment, we use environment variables, and we say the book API is on the red Pi, and the number API is on the black Pi. But, when you push information to the cloud, you don't know which server your code will end up. So we are adding this purple piece over there. So basically, everybody, when we push a Docker image, when we push our code to a server, the first thing that we'll have to do is register ourselves. So when I push the number API, at startup, the number API must talk to someone. Here, in our case, it will be Consul, and said, I'm here. I'm on the red Pi, listening on port 8084. So we'll have to register each microservice so everybody knows who is where. This way we can move things around. So this is called a service registry and discovery. You register a service, and other people will discover this service. So think of it as a DNS resolution. And in fact, we are using Consul. There's other tools, but you can play with networks, routers and DNS and stuff like that. The idea is, give me the number API. I don't know where it is. Just tell me where it is, and I will contact it. So instead of using IP addresses like what we do, we will start using names, book API. And this book API could be anywhere. So when the book API looks for the number API, we have this feign client. Now the feign client will use a name. And Consul, which is our registry, will take this name and say, oh, it's on the red Pi port 8084. This will allow us to have, on the next demo, this will allow us to scale. So the number API will be on 4 Pis. They will all get registered, and when you need the number API, Consul will say, hey, I have Pi 1, 2, 3, 4. Choose whichever you want. So that's a very old thing again. If you come from the Java EE world, that was the purpose of it. Who did Java EE? Yeah, EJBs and so on. In the good old days, you'll you will do a lookup on JNDI and say, please give me the number API book, EJB something. So JNDI was made for that. And that was back in 1998 because it came with Java. Closer to us, Apache Zookeeper. Actually, because we were using the Netflix OSS stack, we tried Netflix, Eureka, but the documentation wasn't very easy, and the APIs were not very easy. So we actually tried with Eureka, but we gave up. We use Consul that comes from HashiCorp. So we'll be using Consul for our discovery and registry service. So what is Consul? Just, a server running, listening on a port, which actually can be used for different things. As I said earlier on, we need configuration. Well, actually, you can use Consul for configuration. If you know that Consul is running on that server, Consul has a map of key value pairs. So the configuration could have been there. We will use that to register our services and look them up. Rebooting the router, not very good.
No.
And Consul, again, like Kibana, like the configuration, Consul becomes a SPOF, a single point of failure. If all the information is there, you kill the Consul server and the entire system will fail. So Consul is made to be replicated. Again, we didn't do it, but we could have. We just could have put two or three consoles running and plugging and plugging. The discovery is dynamic, so each time we push a service, the first thing it does, it talks to Consul and says, "Here I am." And we could have used it for runtime configuration, as I said. So this is how we will be using Consul. So think this code is the same, kind of the same, for number API and book API. So when I push those microservices, they need to register in Consul. So we have a Consul API. We tell Consul, this is the host and this is the port. For now, we will still be using the environment variables, okay? So let's say red Raspberry Pi on port 8084. We create a Consul agent, and then what we do is on this agent, we register our microservice. And our microservice has an ID. As I said, now we won't be looking for IP addresses. We will be looking for names. So here is the name. The address, that's the address that we have. The environment variable with a port. And here there's something important. You can do two things with Consul. One is saying, I could have skipped this line. If I skip this line, I'm just saying, I register the number API on this server. Good. We will go to the Consul dashboard, and you will see that the number API will be there. Except it will be orange. We will show you. Why? Because Consul, you just told Consul that you have a number API somewhere on a server, and Consul knows about it, but Consul also can ping your microservice. That's what we do. You can create several checks. We just created one. So we are telling Consul, please, every 5 seconds, go and do a HTTP check on number API/API/health. So we've introduced a health check. On both the number API and the book API, we have a health, just returns a 200. It doesn't do much. But that will allow Consul to register our microservice and to ping it. So Consul, you have red, the service is unavailable. Orange is there, but I don't know in which state. And green, it's there, and I can ping it every 5 minutes, 5 seconds. You can do checks, different checks. Here we are doing an HTTP check. You can check that the file system has still space. You can do all kind of checks. You can even do some business checks. And Consul's job will be to go and ping this URL to make sure your service is there, but it's also up and running. So this is a health check. You know, you have plenty of tools that do very complex health checks. This is just responding at 200. So if you manage to ping this URL, it's because my microservice is up and running. So first thing I do, I'm the number API, I register myself. Now, the book API needs to discover this guy using a name and not an IP address, using Consul. So again, here I use the Consul builder, and look at that. I'm the book API, and I want one instance of the number API. But you could have several. So here what you're saying is you're asking Consul, please give me the instances of number API. And it will give a list of service. In our demo, we'll only have one, but then we will introduce more. And once we have, you know, the health service, we only have one. So that's why I do an iterator next. So I take the first one because I know there's one. We take the service, the host, and again, the idea is to tell our feign client, here is my number API. So the feign client now has the base host and the path, thanks to Consul. Okay? And this is what the Consul UI looks like. Is it working?
Nope.
No, okay.
We have yours. We have yours.
We have mine. I'm going to do the demo then. Even if it's the full demo and...
well, you can just show,
anyway.
You can just show Consul.
Yeah. So... here is Consul. So because it's the full demo, I have everything, so sorry about that. But if, and I'm going to do like my friend, I'm going to unplug cables. So Consul, as I said, because I've started the entire system, every microservices went, here I am. So for Consul, they are there, but it can't ping them. So the orange, it's because it can't ping. So here I have I have 4 microservices, 4 number API services, but you know we should have had one. So everything is here, but Consul is telling us, well, there's, you know, I can't ping them. So the code that I will show you, when this code here, let me go back to the slide. This code here returns a list of healthy services. That means that this code, when the book API asks Consul for the healthy services, Consul will only give this one. Oh, sorry, it always does that. This one here, this one there, and this one. Not this one because it can't ping them. This is the health check. It's pinging constantly. Working?
Nope.
Nope. So if I plug them back, Consul will, every few seconds, manage to ping the HTTP health check. So there's a lot of mess here. It should only have one book API and one number API. Okay, any question with Consul? Maybe on the next demo.
There you go.
No. Yeah, one question?
How do the services discover Consul itself?
Yep. So how do the services, because you need to know where Consul is. So if you look at the code, let's say the book up. Here we say the Consul is running on localhost 8500. Again, it's an environment variable. So when we push it to the pies, this is replaced with Consul is running on a purple one at the bottom. So here, at startup, as you can see, at startup, we register our service, and we need to give it the Consul host and port. So for development, it's localhost, fine. Because we use the configuration, we override it, and we can say it's on this pie. But in real life, again, as I said, Consul needs to be clustered. And even what you can do is load balance, put a load balancer in front of Consul. So if you have several instances of Consul, they need to synchronize themselves. Consul can do it. So you have different consoles on different data centers, etc. They all synchronize because you need to know where is the service. If one fails, it's not a problem. But which one will you go to? Here, it's hard-coded because we only have one. But again, you should put DNS in front of it, a load balancer, in front of it, and say, I don't know where is Consul. The network will give you the instance of Consul. Each time you have a single point of failure, you need to duplicate it. So, the configuration needs to be duplicated. Consul needs to be duplicated. The logs aggregator, the monitoring needs to be duplicated. Each time you have one single piece of something, you need to duplicate it. Same with Kafka, all these type of devices and frameworks. That's why it's cheaper to do it on a Raspberry Pi cluster than in the cloud. Because each time you need several instances of everything. It's working?
Maybe.
Maybe. Okay, so we've been living in a happy world. I even unplugged the cable and it worked. But what if I unplug 90% of the cables? Well, we need to handle that. There's when the book API talks to the number API, if I unplug the 4 instances of the number API, it should still work, do something, So that's when you introduce a pattern called the circuit breaker. So that's what we're going to do. Nope. So circuit breaker, another pattern. We have 2 microservices. Book API calls the number API, so there's a strong link between both. If we create a book and the number API is not there, the book API will not work. So you want to create a book, and you have a microservice somewhere that you depend on, and it doesn't respond. What do? Shall we just stop the entire system? No. Again, when you work with microservices, you don't deal with occasional failure. you know it's going to fail. So you always have to keep that in mind. And that's really tricky. You know, coming from the Java world, you have an exception and you go, oops, don't know what to do with it. Now you know the exception will occur. Talk to my friend who is struggling with, oh, it's working?
I think so.
Why? So it will fail. And finding a plan B for failure is not always easy. And
redundancy.
In our case, sorry?
Redundancy.
Redundancy. So in terms of business, you know, you need to create a book. For creating a book, you need a ISBN number. This microservice does not respond. What do you do? For us, it's easy. We just create a fake one. But it's real, you know, in real life, you can't do that. So you want your system to keep running. And somewhere you have to say, I've created this book, but with no number, and this one with no number. And later on, when it turns back, you go and set the numbers. You see, it can be very, very, very tricky to find a plan B. So the architecture does not change. It's just between the red and the orange box, we're going to add a circuit breaker. What if this link is broken? What will we do? Circuit breaker. You can have circuit breakers everywhere, even on. We could have put that on the Angular application. You are calling someone, and this someone does not respond. What do you do? It can be between microservices, but also between the front end and the back end. Remember that in our case, we invoke synchronously. So we do a HTTP GET and we wait. And if the service is not responding either because the cable is not there, which is easy for us, but maybe it can be under load, what do? You retry and retry again. So you're putting more and more load. Putting more and more load will mean that I am the book API, and now my job is just trying to get the other microservice. So now I'm busy pinging a service that does not respond. What happens? I can't respond anymore to other requests. So let's put something in between, something that could break the circuit when the circuit does not respond. Again, how do you implement the circuit breaker? You can build your own. There's in Delta Spike, there is actually a CDI extension that does it. So we could have used that. JRUG, which is another one. Microprofile as one too. But we decided to go to Netflix, Hystrix. We wanted to stick to the Netflix stack as much as we could. And you're also going to see why we choose Feign and Hystrix. What is Hystrix? The Netflix implementation of the circuit breaker. The circuit breaker, is just a design pattern. We have an API, very simple one, but the idea is defining the plan B. If the invocation does not work, what is the plan B? So we have a builder to build our plan B. And, it's called a Hystrix command. So this is the algorithm to execute when you can't invoke a microservice. So the idea is the circuit open? If the circuit is open, it means, it's broken. What do? And then Hystrix has several algorithms. Try again. Try again, you never know. Stop trying. How long? What is the timeout? How many times do you retry? So the algorithm can be quite complex. The idea is I'll try to see if the circuit goes back to normal. But if not, there's one moment where I'll do something else. And Hystrix, you can configure Hystrix per microservice, saying wait 2 seconds, try 4 times, etc., etc. And it integrates well with Feign. We will see. So here, so we are on the number API, and we need to say, we generate a book number, and we are sleeping. So the book API is not responding. We could also unplug the cable. If it's working, I hope Roberto could do the same. But let's say the book API is there, but it's under load, sleep. How do we handle that? So that's the book API invoking something that is sleeping. This is what we did, but just to show you, this is a very simple use case, but just to show you the idea. Remember the Feign client, the number API. So I'm the book API, and I'm injecting that. We actually create a fallback. In our case, it's a very simple one. Remember that the book number is just a string. So we return a fallback. It's a string. But here, I could have had a very, very complex algorithm. The idea is now, my Feign client, I put the fallback here. So that's why Feign and Hystrix are a good combination. I don't have a Feign client anymore. I have a Hystrix Feign client. The code is exactly the same. I only have to give it back the fallback. And I'm using all the defaults here, but I could have said, look, Hystrix Feign client, after 5 calls, after 10 seconds, do the fallback. And the fallback could have been easy or complex. In our case, it's easy. So the book API will use the Feign client, so we haven't changed the book API code, okay? It's just the Feign client is different. Now it's a Hystrix one, it's a bit more clever. And the book API tries to invoke the number API. If it works, good. If it doesn't, after retrying, it will fall back. So it will return a fallback ISBN number. So on the demo, you will see that when it works, we have a number API working with a different number. And when it doesn't, we have the fallback. So just one line of code here to say, this is the fallback. Is the demo ready?
I think so.
God, I've been talking, trying to give it time, but...
No, it's fine.
Yeah?
Yeah.
So you want to switch?
Yeah, let's try. Yeah, sorry about that. Sometimes
can you make it slightly bigger? Yeah, cool.
Yeah, sorry about that. Sometimes these things happen. I'm not exactly sure what was wrong, but I have to reset the router and restore all the configuration. Okay, anyway, Antonio already showed you Consul, so now I'm showing Consul running on the Pi. So,
but with only one instance, okay?
Only one instance.
Book and one number API. We will change that.
He was showing other stuff like the tag and the clients. No, here we only have the book API, the number API. If we expand this, you only see like one instance for book API that's performing 2 health checks, and if we move back for number API, again, there is only one instance for that. Actually, if I show you the Ansible result, we're still only using 4 instances. So if you remember from my last demo on the Pies, we had 3, one for the Angular app, one for the book app, another one for number app, and now we're using a 4th instance on the Pi that's running Consul. So now, hopefully, I'm coming over here to Consul. Here's my services. I'm going to, actually, let me do something first. So here's my store.
Show it
Yeah.
when it works first.
So here's my store, so I'm still able to retrieve some book numbers. Now I'm going to plug these cables over here. I'm not exactly sure which one is running, but I know at least it's one on the top. And now book number is not working anymore. If I go to Consul, hopefully, if I refresh, it's going to be orange. So now it's not able to do the health check on the number API. But that doesn't mean I'm not able to create books anymore, because now we introduce the circuit breaker, and then we can have like a fallback number. So now, before, as you remember, when we had the local host problem with the config, I tried to create the book number, and everything was not working. Now I'm going to my store, go here to my books. Actually, I already had one that I was trying, but I come over here, I create like a book, hit save. It takes a little bit of seconds to figure out that there is a timeout, but now I'm able to create the book and get like this fallback ESPN number, of course.
We didn't use Hystrix on the client side, on the Angular app. We could have. That's why when it generates number, it goes pending. But we could have used also that on the front side. So doing, the Angular app will have a fallback something.
Yeah, so the fallback is actually working on book API, not on the it's not wired into the
so
number
now
API.
if you plug cables back in,
so if I plug the cables back in,
create a book, create a new book.
Let's have a look into Consul. So now that one is up. So let's go over here. And we go to numbers. Numbers are there. So let's go to books. And we got the fallback ESPN number. So it seems it's not really working.
Do it again. These things take time.
These things take time. Nope, that's not really working.
It will work.
It will work.
Keep on hammering.
I keep on hammering.
We're cheating. We're just returning a string called fallback, ISBN. But you always have to think of a plan B, and it's quite difficult in terms of business. You have to go back to your users and say, okay, you told me you wrote this story, and this is what happens when it works, but what happens if it doesn't work? And for your users, that's quite tricky. They will go, no, it has to work. That's good. Okay, but most of the time, hopefully. But so it's tricky for everybody. It's tricky for us to implement, but it's tricky in terms of business. Okay, so one reason to do microservice, to go through all this pain, is to be able to scale. So now we will be adding more nodes, and we need to load balance on those nodes. Scaling, that's the number one reason why you will do all that. So we need to scale our microservices. We're going to have 4 instances of the number APIs and 2 instances of the book APIs. So that's what we're going to do. They will be all registered in Consul, deployed on most of the pies now. But now we have an issue. Which instance to choose from? Always remember, I am the book API. I need the number API. There's 4 instances now. Which one am I going to choose? So this is what we will be doing. The orange guys are the number APIs. Oh, we have 1 instance of book API in this demo.
Mm-hmm.
Yeah, slightly getting there. So now the book API will ask Consul. We always, from now on, we always have to go back to the registry service. So the book API needs to invoke the number API. First thing to do is ask Consul the list of healthy servers. And Consul's job is just to give you the list of healthy services. Consul does not do any magic, tricky load balancing or whatever. So Consul will tell you, well, you have 4 instances, here they are. So the list of health server, that's exactly that. Consul will return 4 instances. Which one to pick? That's when you need a new pattern called client-side load balancing. We know what a load balancer is. It's usually hardware, it's replicated, it load balances with different algorithms, blah, blah, blah. This is the same idea, but on client side, on my Java code, on the book API Java code, I'm going to have to ask Consul the list of healthy services, but then I'll have to do something, round robin or something. So it's the client now that has to do this technical job. There are several instances to choose from. Which one you're going to choose? Round robin, it's easy, but you have other algorithms. Capacity, this pi is under load, give it a break. When you are in the cloud, you can also go and say, I'm on the East Coast data center. Please don't go to the West Coast. Stay here. So there's more clever things that you can do. Multi-tenant, that also becomes tricky. Just go to my instances, not my neighbor instances. Again, how do you do that? Several ways to do it. If you are on Amazon, you actually have the ELB that you need to pay for. The good old Apache HTTPD that does that. Nginx also does it. We use Nginx for the Angular app. We can do that. But we will be using Netflix Ribbon. So Netflix Feign, the HTTP client. Netflix Hystrix, the circuit breaker. Netflix Ribbon, the client load balancer. What is Ribbon? The Netflix implementation of the client-side load balancer. Fault tolerant, again, is clever enough to say this instance is down, don't go, etc., etc. We will be using HTTP, but Ribbon can do other protocols. We will have a synchronous model, but it also can use a reactive model. And is clever enough to cache things, because you don't want to try every time. You can say, look, for 10 seconds, don't go and ping Consul, use your local cache. The book API is on server A, B, C, D, so don't ask for it all the time. So it can be quite clever. And it integrates well with Feign. Feign, Ribbon, Hystrix are really good. It's just one line of code, and Feign, Ribbon, Hystrix do all the work. So here, I don't know if you remember, but on the previous demo, we only had one number API. So we tell Consul, here is the number API. That's the name, one unique name that is used by the book API for looking it up. But then you need an ID. An ID must be unique. On the previous demo, we just put the string number API because there was only one. But here you need a sort of unique random ID. What's important, for us, it's the name of the service. But because now there's 4, the ID has to be unique. So we put a UUID. So that's one thing to be done. Then we need to plug Ribbon. We need to register Ribbon. And what's important, I forgot what's... So that's the string number API. So we go to Consul and said, can you give me the list of servers that have number API? and Consul will give 4 instances. Then we say, look, ribbon, we're gonna, you will get the list of servers. So, again, they have several strategies and so on. We will set up a rule. We will be doing round robin. The refresh interval, how many times you will go and ping those servers. Because what is more effective? Either ribbon every time will go to console, pick up the 4 instances, choose one, go to console, pick up the 3 instances, one is dead, choose one. Or you go to console once, you get the 4 instances, and every 10 seconds you ping those 4 instances and make sure they are there. And if they are not, you update your own cache. You see, there's little tricky things to be done now. Remember that we just want a website with books. Dead simple. Yeah. So now that a ribbon is configured, we go back. We ask a console to get the list of healthy clients. We get a list of healthy clients. We stream on this list. And where is service? Yeah. And now, thanks to Hystrix, it will create the URL of the one server to be pinged. And again, Hystrix faint client. Here now we have the number API, which is the name, so we don't know in which server it is, and we have the fallback. So all the pieces work together, and Roberto, is the demo working this time?
I think so this
yes.
time. Yeah, so now I think it's going to be a little bit easier. So now again I have console. So actually it was like unplugging and plugging stuff like 10 seconds ago.
So when you see 8,
so
it's, remember these 4 instances, the name of the instance and the health check. That's why you have 2 on each server. And we could have as many health checks as we want.
Yeah. So now, as Antonio was saying, we have here 4 instances for the number APIs that are registered here on console. If I show you the Ansible output now, you see that there are a lot of instances on the Raspberry Pi cluster. So I actually deploy the number APIs on these Grom server 1, server 2, Troll server 1, Troll server 2, and these are the orange Pis. And so if I go here to my store, so now I'm demo 7, and I'm going to create a book, whatever, hit save. Oh.
Fallback.
Fallback. I'm not. This was like working like 10 seconds ago.
Thank God we have a circuit breaker.
Yeah, I'm speechless. Okay, there you go.
Why? Go and check the logs.
Yeah, exactly. So now I'm getting probably it was like didn't have timeout properly. So now I'm getting book numbers. So now I'm gonna just connect just one. So I still have 3 number APIs up. So if I go to console again, now we'll see it. Hopefully one of them will be down. There you go. Yep. So that one is orange. All the rest are healthy. And if I go here to my bookstore again, and I create a new book, hopefully. Let me delete these. But hopefully I'll get a proper book with a book number. So here we go again. Awesome, that's working. So now I'm gonna unplug all of them, which are the orange ones. Crap. And I actually got shocked over there.
Really?
Yeah, that's why I say.
Gee,
yeah.
Microservices are,
they're painful. They're painful. Never happened actually, and I'm tired of unplugging cables. So now I'll go to console again, hit refresh. So all of them should be down. There you go. So there is no number API working anymore. If I go here again to my store, now I should be getting the fallback. Hit save. Now fallback, that's working. Now I'm going to try to unplug just one cable.
But if you go quick, you'll get the fallback. Remember that it's full of timeouts now.
Yeah.
Feign has a timeout, Hystrix has a timeout, Ribbon has a timeout. So now if you create a book, you might get a fallback, even if Ribbon has discovered it, but Feign doesn't. You know, it starts to be very, very tricky.
So one is up again. So we didn't. One of the things we haven't done, we didn't really perform performance tested on the timeouts, right? To see what were the best timeouts to make sure that everyone was streamlined when you disconnect and do stuff. But for demo purposes, I think that works okay. Anyway, of course, in production we have to really see what were the best timeouts that you should use on each of these softwares.
You see how he's talking and talking before hitting the button? Because he wants to make sure all the timeouts have timed out?
Yeah, exactly. And I'm timing out right now. Yeah. So let's delete. So make sure that, okay, I'll just leave your book again. So let's create one. And now, I have book number and only one. Yay! Okay, so...
On the last demo, when we start to put load, funny things happen because we unplug cables while clients are hammering, and some clients will keep on hammering a dead server, and then it comes back, but the timeouts are not there. So when you go on the logs, you have all sorts of funny things, and
so
quite tricky.
So sometimes. Now I plugged in all the cables. Now all the services, all the number APIs are healthy again, and now I'm going to get the fallback. Hopefully not. So let's see. Hey. Okay.
You know, I was waiting for the fallback, and then you need to explain it.
Yeah.
Okay. Reaching our last demo. Oh, no, sorry, not completely yet. You change screens,
sorry.
please? Thank you. So, now we're going to hit another problem is not everybody can create books. Only if you are logged in, only if you are an administrator. So security is hard. Security with microservices is bloody hard because every service has to, deal with mostly authorization. That's what we will be doing, adding a token. So security. Number API is public. Anybody can use it, fine. Book API gets, HTTP gets are public too, but we want post, put, and delete to need an authentication mechanism. So now comes a very important pattern, again. Think of all these microservices here. At the moment, everybody can call everybody. So each call can go through any cable. But we need to centralize this authentication mechanism. We need, if everybody goes everywhere, who checks for the username and password? Who creates the token? Who passes the token around? So when you deal with authentication and other cases, you realize that you need a central point, a central gateway where everybody will go through that gateway. And the gateway will be then the one filtering, saying you can access the HTTP delete or not. So now we're going to have to put a gateway, the second purple box. We will deploy a gateway, and all the calls. We didn't make that happen, but it's not visual here. But the call between the red and the orange, also go through the gateway. So the gateway is everywhere now. we put that there, but every single red line going from one service to another one now will go through the gateway, and the gateway will do the job. Do you want to talk about the gateway? That's your baby.
Yeah, sure. So as Antonio was saying, like there is a lot of API gateways out there. So we at my company we built our own gateway as well. So it's not like a sales pitch, but basically we wanted to use the gateway on this demo as well, so you guys can also see how we do stuff. So the gateway, think about that as a proxy. So if you any Apache model rewrite users here, few and Nginx, okay, a couple. So usually you use these to like proxy your request, maybe because you want to change the URL, maybe you just want to centralize something and you want to expose it to the outside. So the gateway mostly works as a proxy. So instead of like having like these overcomplicated address like book API /book/numbers or whatever, you can just change it to a completely different URL, and you don't have to expose the 8080 port. So you can just expose the 80 on that proxy. That's how you just do it. It just supports the endpoint on the load balancer on the proxy, and then it's a more familiar or more friendly endpoint for your customer. And then instead of just calling the endpoint directly, just call it for the proxy, and then the proxy will just do the conversion to whatever service needs to call. So it's actually something that's becoming very important on this microservice architecture. So because on the gateway you can just like orchestrate all your microservices with all the endpoints, then you can just like change configuration over there, and you don't have to expose all that complexity to your customers. So there are several to choose from. There is Amazon API Gateway, works very well. There is this APG Gateway as well, also a good product. And then there is this TribeStream Access Gateway, or API Gateway actually. We actually renamed to API. That at the moment is like in beta, but if you want to have a look, please have try it out, and we'll be happy to help you with that. And what is the TribeStream Access Gateway? So it's an API security for microservices. The idea with this gateway is instead of you having to code all the security, all the role checking into the Java code itself, you can actually set it up as a configuration layer at runtime, and then you can just intercept.
Sorry.
No worries. You can just intercept the request before hitting the endpoint that you want to call, and then the gateway will apply authorization, will apply authentication, and it will fail the request or not, depending on your security credentials. So the gateway has an OAuth2 token provider. Who knows about OAuth2 or use OAuth2? A lot of you, awesome. Also has JWTs. Who's used JWT? Of course, a lot of you as well. We do have implementation on HTTP signatures. Who use HTTP signatures? Not that many. Well, HTTP signature is something that actually allows you to sign the request with a private public key. So it allows you to make sure that your request was not tampered. So we actually use this to, like, when we generate the token, we can also sign it. And then we can make sure that no one tampered with the token, and then we just sign it when we get it on the gateway. And if someone tampered with the token, we'll just know, and we'll just discard that request. And we use it to route microservices from one to another. So for the people that know about Apache model rewrite, that's some of the syntax that we use as well. Also acts as a load balancer. So we discussed a ribbon client-side load balancing. Now here's going to be like some server-side load balancing that we're also doing. So JSON Web Token, do you want to continue now?
So the idea is, here we are, we need a user password to log on. That can be on a database or whatever. Authentication will be made, in our case, by the Angular application. User password, checks the database, yeah, good one. Now the gateway will create a web token, and this token will be passed around and around and around. So the it's very lightweight. That's why it can be passed, around. It can contain some information. The basic ones are, the expiration date of the token and so on. It's a base 64 token, so by default it's not encrypted. It can be encrypted. And because it's lightweight, now it will be passed around. So I log in, good username and password. The gateway gives me a token. Now I have to carry this token all the way through all my web services. Microservices.
Mm-hmm.
So this is a token. Okay, if you put some color into it, it looks like that. So the token is made of 3 parts. Actually, there's different kinds of tokens. We talk a lot about JWT, which is now a specification, but there's the macaroons coming. I don't know if you've heard about macaroons. I'm not talking about the French president, Macron.
Mm-hmm.
No, not this one. The macaroon, which is a token, because a JSON Web Token is immutable. It cannot change. So you'll pass it around like that. A macaroon is a bit more agile, so you can add data throughout the calls. So a macaroon is a agile token. So that's what we will be passing around. So as you see, it's not too long, so it can be passed on the HTTP header. And this is base 64. It's not encrypted. So if you just unbased it, the blue part is just the header saying the algorithm used to encrypt or not the token. Then you have a payload. That's what's important. So each time it starts with 3 letters. That's part of the standard. So sub is the subject. That's me. ISS is the issuer. The token was given by that URL. The IAT, it's, God, I can't remember. Exp is expiration date. AAT, it's creation date or something like that. But then you can add more orange parts. One very typical one, which is not in the, in the spec, but you can pass around, is your role. You just logged in, so you are an administrator. So here, you can create your own token, and you can say the role equals admin. This way, the token goes around, and you know that a Goncalves is an administrator. Then you can allow it to do different things. So this is what will be passed around. So because we do that on the Angular application, on the client part, we need to ask for this token. So when we do user password, what we'll do is, where do we put the token? Oh, I can't remember, anymore. But let's start simple. Not good. Sorry. We thought it would not be geeky to have PowerPoint slides, so we went to Reveal.js, but sometimes it's a bit of a pain. But it's geeky, isn't it? Sorry. Oops. But what's important is once we have the token, we put it on the HTTP header called authorization. So we put the token in authorization, and once we will be then invoking the Book API, this token will go from the Angular app to the Book API app and through the gateway, and then to the Number API. And we will have to pass this token around. So here, when we do the delete, so when we are on the Angular app, we can click on delete. We've been authenticated. We need to pass the token in the authorization header. So now when I click on delete any action, I have to put the token And the gateway will tell me if I'm allowed or not. Are you ready for the demo?
I think so.
He's on Stack Overflow. Not a good sign. Not a good sign.
Not really.
When in the
good
middle
sign.
of a demo you go to Stack Overflow, that's not good. And we only have nine minutes for the last demo.
No, it's all good.
So you want to switch screens or
Yeah.
Stack Overflow? Not good. Not good.
Over here, okay. Okay, so now we have our store again. So we actually haven't changed anything on the both number or book APIs. But the only thing that we did was introduce the gateway layer in the middle, so we can have security. Yes, sir? Oh, okay. So we only have our gateway in the middle to provide the security. Now, if I come here to my demo and I have my books, and let's try to create a book, something, I get an error, and let's see what it is. So it's a little bit small, but if we expand this, I'll get requires HTTP authentication, and basically I get a 401 over here. 401 unauthorized. That means because I haven't logged in with my user. So now I'm going to log in. Over here, sign in. So we have like an awesome sign in feature. Okay, I'm logged in. I call like an auth endpoint that gave me the JOT token that Antonio was talking about.
The bearer.
The bearer. So actually, I'm going to do actually something really cool, which is I'm going to copy this JSON web token. And I'm not sure if you guys know about this cool website called jot.io. And you can actually paste your token over here, and which basically just unwrap the information that you have. And you can see that this access token was generated on that token endpoint, and the name is Goncalves because that's the username that I've used. And I'm granting types for, my grant type is a password because that's one I've used, and there is the profile for books, meaning that I'm able to access the book. So this is just a minimal token. Of course, you can pretty much add whatever information you want over here. And there is like Antonio's email as well. For that bookstore. So now, if I go to my store again, go to my books, let's create the book, and wherever, hit save, and there you go. So I was able to create a book. So now my user is authorized, and I'm able to create books, delete books, and do whatever. So I'm actually going to do something interesting here as well, which
we have 6 minutes.
Oh, really? Oh, well, it's super fast then. So I can like do a curl, and basically I'm doing gets, and the get is actually authorized because I'm not passing any authorization because basically I'm not securing the get. I'm only securing post, put, and delete because those are the things that can change the database. And now if I, for instance, try to do a post, then I get 401 over here. And this is done with with this gateway that I've showed you. So what we have is we have all these accounts. It's Antonio account, there is Roberto account.
It could be on the database or LDAP server.
So this is integration with databases, APIs, LDAPs. In here, we didn't do user integration, want to keep it simple, so we just added the users and then we added the password. So you can either have a combination of both, have LDAP and internal users over here. And that gives you the login and password to get in. And then here, basically set up the auth2 token, so you can grab the token from that endpoint. That's something that we call on the UI to grab that bearer token. And we have the grant type for password. You can have refresh tokens. We can have even a client ID, so you can have like an additional secret sent over there. And you can, of course, set up like the expiry policy of the token, and so on and so forth. Finally, we have this piece over here we call routes. So on the route, and this is using this mod rewrite syntax coming from Apache. So if you're using Apache, you can pretty much copy all the configuration that you have and paste it over here, and it will just work. And I set up like this read-write condition saying, if the method that I'm being sent is a post, a put, or a delete, then I want to execute this rule, which is pick up books. I'm going to send it to this book API host, is an environment variable saying where the book is working. And in the end, there is like these flags that are going to say, I'm going to apply proxy on that, and I'm going to apply authorization on that. And then the authorization, we can apply it over here. We'll just say, remember that token that I've shown you, that when it generates a token endpoint, where Antonio and me are associated, we'll just say, I want to apply the authentication that it's being given by the token endpoint called books, and I put it over here, and just mean that when you have this flag A, it's going to apply the security profile authentication on that rewrite rule, and basically will just authorize or unauthorize the user. If there is no match on any of these methods, then it will just evaluate the next rewrite condition, which is basically going to be get or heads or what's the options. Doesn't really matter, and it will just like allow the user to pretty much retrieve the books and see a review of the books. It's not allowing the user to actually editing or changing or create anything else.
Shall we finish? So far, so good. So we have plenty of microservices all over. They all depend on each other. Book does not work without number API. Now we are introducing clients to create some load. We have several services. Things can go wrong, and actually things always go wrong.
And they did.
So this is the final first demo. We have the Angular app, 2 clients hammering with load, doing get, post, put, delete, authenticated or not. That's why we have different error codes. Consul, the gateway, which is all over, the ELK, which is there, and this is how it looks like. And
it looks sad.
Yeah, it looks sad, yeah. So these are the 4 number APIs. These are the book APIs with the different codes because we have clients hammering. These are the counts, and you know, I promised that we will burn a few pies, but I'm not allowed in the building. But if you unplug things, it will change, you know. They will stop creating logs. Kibana will stop grading logs, so now there's only 2. But we will see different errors now because, you know, when we unplugged them, the circuit breaker kicked in, the timeouts, etc., etc. And yeah, if we unplug the console, you know, everything dies. Also the gateway. So the gateway has to be redundant. Console has to be redundant. Everything has to be redundant. So just as a recap, remember that we just want to display books. So that was our first demo. 1 Angular app, 1 microservice. But then we thought, no, you know, we need the book API to talk to the number API. Without the monitoring, I think I had fixed the images size.
Cool.
We have the ELK at the bottom. Monitoring is something you have to put very, very quickly. Then, because we change environments, we need to introduce configuration. Because we moved things around, we need a registry. That's where Consul came along. Circuit breakers between microservices. Load balancer, remember ribbon. Now the book API has 4 instances to choose from. Which one? Security, when you need security, you need a gateway, and you need gateways for all, you know, other things. And then at the end, we created some load. it's not complete. You know, as I said, the console has to be duplicated. Same for the gateway. Same for the config server, etc., etc. So, just for a single web page to create books, we need that, and that, you know, even that is not enough. And we use many microservice design patterns: the circuit breaker, the client load balancer, the gateway, etc., etc. But there's more. You know, there's plenty of books with plenty of patterns. There's, you know, it's very complicated, very complicated. Thank you. There was something more.
Yeah, there was. I mean, we have.
Before saying, oh no, sorry, it's just at the bottom. Yeah, the conclusion, the lesson learned. Microservices are hard. When you just type code and you leave others to do the hard work, that's fine. But we have to do the hard work, and yeah, it's bloody hard. So, of course, you will not do that on Raspberry Pis, but remember, with all the good DevOps things, you will sit down next to your ops and you'll try to explain it to make all that work, and he will look into your eyes thinking, why? Why are we doing all that? We need to integrate a lot of infrastructure, run on different environments. We didn't show you, but we actually have a Docker Compose file. So this works on my local machine, on Docker Compose local, on the Raspberry Pis. So it has to run on several environments. When you go to a microservice talk, they always say microservices are all isolated. Use whatever technology you want. We stuck with Java and TypeScript, and that was bloody hard. So if you have to maintain Go, Node.js, Java, Scala, either it's completely isolated teams, and fine, you don't talk to each other, but it's bloody hard. The more technologies, the more languages you have, the harder it becomes. Because what's difficult is the integration. Remember that the number API is just 5 lines of code. So it's not the, in this demo, the business logic wasn't difficult. And we didn't have databases. We didn't have complex business logic. We didn't have a complex network. That's easy. And we didn't duplicate all the SPOFs. So, we needed more hardware to do that. And we didn't use asynchronous events, which is very handy when it comes to microservices, but it's bloody hard, a Kafka, to make a Kafka run, you need at least 3 nodes, otherwise it doesn't make sense. And we didn't do integration testing. There's a talk this afternoon about testing microservices. We didn't write, integration tests because it's hard. It's really hard. And we wanted to introduce Zipkin, to show you distributed tracing, but we ran out of time. And rate limit also. You can say, please call my number API only 500 times an hour, only on weekends. So your APIs don't explode.
Actually, the gateway supports rate limiting.
Yeah, so the gateway has to do that, etc., etc. What do other things? Because we thought, God, everybody's talking about microservices. Everybody loves them, but not us. But no, it's not. We are not the only ones. We asked on Twitter, what do you think about microservices? So we got that. We also got that. I quite liked it. Architect dreams, developer's nightmare.
Yeah, I like that one as well.
And ops too. It is we are not GAFAs. Yeah, I think scaling is is the number one benefit about microservices. If you have 1,000 clients, that's fine. If you have 1 billion, that might be different. So we don't have all the problems of Twitter and Google. I quite like this one. Is Simon Brown saying, if you can't build a monolith correctly, why do you think putting network in the middle will help? So think about it. But there are several advantages, and it's quicker, smaller teams, agile, scale, etc., etc. You can easily go to the cloud. Plus, everything is Dockerized, so you can move that along. So there are plenty of advantages of microservice. You should go there, but start with a few Raspberry Pis if you want. Yeah, use this type of architecture if you need it. But to be honest, more and more people are starting to need it because IT evolves at a very fast pace. And that was the final thank you. Thank you.
Thank you. So, after all of these, we asked the question who was liking microservices, and I think all the room raised their hands. So
Yeah,
who still likes microservices?
Oh, less.
And they still love it. We'll still hate it.
Yeah, thanks, Tommy Tribe, for all the pies.
Yep.
And if you want to know more about microservices, there's actually an entire conference in beautiful Paris about microservices, because it's so hard that we thought, let's create a conference just for that. Thank you.
Thank you. I have a couple of T-shirts here if any of you want them.
We have a couple of pies if you want.
Yeah, a couple of pies as well.